Hello everyone, my name is Petr Styblo and I'll spend some time talking about OpenTelemetry. So this is going to be a talk about OpenTelemetry and learning. This is not going to be very technical, but I'll share with you my personal journey with OpenTelemetry, how I approached it, how I learned it, and I'll especially spend some time with the OpenTelemetry Demo application, which proved to be instrumental for my understanding and for my practical work. About myself, I work as technical sales at IBM. I see mostly younger faces, so if for those of you who don't know what IBM is, it's a company who does computers, mainframes, also typewriters, and a bunch of software. I cover multiple countries, and my background is monitoring, currently AIOps and service management. Service management, again, this is a legacy, probably not that much used today. I do have Kubernetes background, OpenShift, and I spend some time with Service Mesh. And I also contribute to a couple of open source projects, the OpenTelemetry application being one of them. So let's start with OpenTelemetry Primer. What is it? I'll be very brief. I don't want to teach you OpenTelemetry today, but what it is, it's a project, open source project, and basically an observability standard. It has been founded in 2019 as a merge of two parallel, maybe competing technologies, open tracing and open census. So today it's a very mature project, currently incubating CNCF project, and the founders, Google, Lightstep, Microsoft, and Uber, have been joined with a number of other companies. It's a very hot project. I think this slide is quite familiar, so you might have seen this picture before, because why I'm showing that, if you look at the picture, OpenTelemetry is, in terms of popularity in the community, number 2 after Kubernetes. So it's a big one, it's a big project. There are a lot of committers, a large community, but also a lot of bugs and a lot of movement inside of the project. That's why it is being on the top position. OpenTelemetry defines a few, works with a few signals. We call it signals. Those are the dimensions that telemetry works with. Let me just summarize those traces. Traces is the big picture between what happens between services and what are the latencies between services. Metrics, you all know metrics, you all know Prometheus, so those are the time variables. Logs and baggage. Baggage is something that we carry along with between the spans, along with the traces. So it's a context that is being propagated along the way. And finally, profiles. Profiles is a signal that is currently in the process of adoption in OpenTelemetry. So it's not an officially supported dimension or signal, but there is a work in progress to make it happen as profiling becomes a very important dimension in the overall observability world. So there is an OTel, there is a link I can provide later, which defines the rough specification, and there's a special interest group that is working this out. What are the components of OpenTelemetry? Again, very briefly, API, this is the data types, so what kind of data OpenTelemetry defines, the interfaces for the data, whereas SDKs are the concrete implementations in various languages. Very important part of that is the data. This is defined by OpenTelemetry protocol, which defines the data format that is being carried over, and the span format, and so on. Then there is also something called semantic conventions. This is a very important topic. I think you will hear more about that later in the following talk about OpenTelemetry. This is basically a common understanding and common meaning of things that we name and what kind of names have what the names have, what meaning those names have, right? So this needs to set some common ground so that we have mutual understanding, so that technologies generating data understand each other. There is also something called collector. Collector, it's an agent that has inputs and outputs, receivers and exporters, and does various things on the previously mentioned signals. So it can forward the data, receive the data, export the data. So it's a very universal tool that you can mix the data in. There's also automatic instrumentation. So I'll mention instrumentation later in my talk. But automatic instrumentation means that we don't need to do everything manually by programming, but we can also leverage some automation technologies or techniques that help us inject the required instrumentation into the code automatically for us. There is a Kubernetes operator that takes care of the auto instrumentation. That's one part of its job, and the second part of its job is the overall life cycle. So this is what operators do. They ensure life cycle of applications. So it installs the collector and maintains its scaling and the overall life. Let's move on to the OpenTelemetry Demo application. This is a demo application that is being developed by the community, by the OpenTelemetry community. So it's part of the project. It's part of OpenTelemetry, let's call it this way. And it's a fun way to illustrate, showcase all the features and functions of OpenTelemetry. It's very much a web shop application. The theme has been chosen quite obviously in the sense of observing things, observability. So it's an astronomy-themed shop where you buy stuff related to astronomy. And it is a microservices application that consists of many components. In order to showcase all the functionalities, there are 11 languages covered. So this is pretty much all of the languages that OpenTelemetry supports, except one, which is Swift. For some reason, Swift doesn't have enough love in the community, so that there was no volunteer to create a Swift-based service that would complement the demo. But so if you are a Swift developer, you volunteer and go ahead and create a service. What the demo provides is a showcase of those of the instrumentations with idiomatic instrumentation. That means there are like best practices applied for each individual language, so that it's a great way to look at how things should be done in a particular language or framework. It covers all signals, traces, metrics, logs, and it grows. And it's a project that gradually grows. So whenever we have profiles, for example, they will be included. It is deployable as a Docker Compose or Helm. So developed by means of Docker Compose for simplicity on a single host. If you want to run it on Kubernetes, go ahead and use a Helm chart that makes it very easy to install, deploy on plain vanilla Kubernetes or OpenShift or other flavors. It's a straightforward installation, and it includes a backend composed of open source tools. So particularly Jaeger for the traces, Prometheus for metrics, and Grafana as the common UI. In order to make it usable for demonstrating the different functionalities of the OpenTelemetry, it also has a service called Feature Flags, which allows you to toggle various different scenarios that you can play with. Yeah, so it injects errors in different services and makes it interesting to explore. So you can use that tool. You can use the demo for some labs where you want users to troubleshoot, to use the backend to actually come up to the root cause of the problem, for example. The demo it's a project that is really meant to be forked and hacked upon. It is recommended by the community. It is meant to be forked, so there's no policies, no legal issues with that. Go ahead and fork it, hack it, use it. There is a SIG call for that on Mondays. SIG is a special interest group call where the community maintainers talk about the future. There's also a Slack channel that is probably a more approachable way to participate for newcomers. Interesting fact is that the release cadence of the demo, it has nothing to do about features, functions, etc. It's just a showcase. It's a bragging application. So they usually release on KubeCon dates. So whenever there is a KubeCon, there is a release being targeted for. Simple as that. So here is the diagram of the demo. I don't want to comment this too much. It's just to illustrate the complexity of the services. You see all the colors, all the languages are represented except one. And there are also things like queues, Redis, cache, there is Kafka, there is Postgres database. The data exchange between the services it's either by HTTP or gRPC, so it's not a trivial example. So there are even some complex data structures involved. So it's a pretty complex application for a demo. If you want to give it a try, just go ahead and try. Take a picture, go to the URL, and do some shopping. So there is a link that you can use for the main demo, and there are other endpoints that allow you to either open up the feature flag service, so you can toggle the features. You won't see probably anything happening on your demo, but you would see that in the corresponding backend. There is a UI for Jaeger and Grafana. Let me give you a flavor of what the demo looks like for those of you who are not able to open it up. Prepare your credit cards. We accept credit cards. We also accept cash when you're buying your telescope. So go ahead. If you don't have a credit card, want to pay cash, just meet me outside the room. So you can select whatever. I'm sorry, I don't share. Can I make that shareable? I'm trying to show the. All right, so shopping for telescopes and tools for watching stars. Does that work for you, or does it not work for me only? It's dead? Okay, so this is the, thank you, demo gods. This is always happening. So yeah, too many users. Yeah, maybe that's the case. So try later. It should be open. I'll go back to my presentation. That seems more safe. Anyway, so go ahead and try it. It's a fun way to explore. I just need to find my notes here. So what I want to carry on with is why I'm talking about the demo. So I told you it's my personal experience of getting started with OpenTelemetry, learning OpenTelemetry, and I found it particularly useful to do that. So I picked up like 3 use cases for the demo that might be inspirational for you as well, might be useful for you. So first is obviously learning. So learning OpenTelemetry. Before you jump onto the demo, if you are new to OpenTelemetry, here's what I recommend. Trust me or not, but this is the path I took, and it proved quite okay. So start with the docs, first of all. Yeah. the OpenTelemetry documentation is actually quite good. Yeah, it's worth reading. There are a lot of conceptual things if you want to get an understanding of what OpenTelemetry is, what tracing is, what context propagation is, and all the different terminology. But there are also very good tutorials that guide you practically through getting hands-on on a particular language. So I found concretely a very useful tutorial for Go language. It's very explicit, very step by step. It's very easy to understand and follow. And second one that I can recommend is the collector builder, which is also very detailed. It probably lacks on some generic concepts, but probably this is fine because it's a very practical tutorial. So those are the ones that I went through, and I think they are quite useful. Now, the next step in my case, or that I recommend, is run and build the demo. Yeah, so run. You can run it simply by running the Docker Compose or Helm, but I prefer to actually get the source and build it yourself so that you can see what's happening behind the scenes. Then pick a language and dig in simply. So it's a demo app that has 11 languages, so I'm sure that you will find your preferred one. If you are a Python or a Ruby developer, or if you want to go crazy with C++, it's all there. And every language has some idiomatic ways how to do the instrumentation of the code. So you will find, how different languages implement the telemetry. So just go explore the code and try to understand. Then the next step would be just, I call it mend and bend. So fix whatever doesn't work for you. Try to see, how things work, and maybe fix it for you, or tweak it the way you like. Like adding attributes, adding items in the shop, or adding services, whatever. Finally, and this was my case, connect your own backend. Yeah. The reason why I was using the demo application actually was that I work for technical sales, so I'm representing a vendor here. So I wanted to showcase OpenTelemetry on a vendor backend other than the open source backend. So I had to fork it and adjust it, tweak it, enhance it so that it works fine with my concrete backend. And that's a great way because you will find, although you might believe that OpenTelemetry is a standard, so everything should work, it's not that's precisely the case. There are many moving parts, many things that may go wrong, or may go different. Every vendor, every backend treats things a little bit differently. So it's a very good way to explore. Also, another tip is play with the general OpenTelemetry data. So you have, traces, logs, profiles, traces, logs, what I forgot, metrics. Thanks, and you can mix them. Or you can combine them inside of the collector. Collector is a very powerful tool. I think this will have a bright future in the project. So it's definitely worth to play and spend some time with the collector. And finally, as part of the learning experience, if you want to really get your hands dirty, find an issue that you like on the project and solve a bug. Really, most recommended way how to learn things, because it seems like a simple bug, but sometimes you get into areas where you never expect it to go, and this really opens up, the world for you. So this was the case for me, and I've participated on a number of bugs that I really didn't want to initially, but it was worth it after all. Another use case that I think might be good for considering is, like, after you started with OpenTelemetry, after you are familiar with it, maybe you want to apply it in your daily work, in your project. So prototyping. It's really talking about the demo and OpenTelemetry in general. So talking about the demo specifically, the demo is really good for testing things and testing your own backends. Yeah. So if you want an app that is out of box, that is ready, that is reasonably complex, check it out, connect it to your backend, and play. Also very good, as I mentioned earlier. It's really a good way to test the instrumentation code. Like if you want to instrument your own your application, you want to test it. So plug it into the demo, and it's also very useful for exploring the general concepts. So thanks to the templates that are available as part of the demo, you can take inspiration of one particular service and basically do it similar way in your concrete project. So some of what I mean by templates here is, for example, a ready-made Docker files for each for individual frameworks or languages. The skeletons of the instrumentation. So it's very practical, very useful for other things than just the demo. Yeah, the backend is available. So you might, in your prototyping experience, you might just leverage the backend that is out there, that is ready to run. So you don't do anything; it just runs there. So it offers the OTLP, OpenTelemetry Protocol endpoint. So you just connect whatever application you have. So if you just want to test your own OpenTelemetry instrumentation, go ahead and use the demo just for the backend. If you don't like the demo itself, just go ahead with the backend. There's also a load generator included, so you can use that for your own projects as well. The demo is great for studying how context propagation works and baggage propagation. So for me, this was something that I spent some time with. So that's why I'm mentioning that. It was particularly important for me when I'm moving on, mentioning our own backend and our own instrumentation. So just in a minute, I'll mention that. Collector config testing. So as before in the learning part. Great for testing the collector. It's there, it's out there, running there. It's connected to the backend, so no worries. Just connect data to it and play. Feature flag. Well, maybe a little bit artificial example here, but if you like to create your own scenario, maybe you have customers that are specifically asking for some kind of a scenario. You can build your own scenario and implement it as a feature flag, so you can totally on and off and have it at your disposal whenever you like. And finally, we are on the community event. So I think the aspect of contributing to community is really important here. So what I want to say here regarding that in relation to the OpenTelemetry demo, it's a great way to start contributing to the community. Whatever of your previous experience is, it's a great way to contribute. Either you want to add something valuable or you just want to become part of the community just for the fun of it. The demo is great because it's just risk-free. It really is nothing but a demo, so no big deal really. If you break something, nothing much happens. Also, a good thing that I find particularly nice is that because we have such a breadth of coverage, like those many languages, there is no single guru that would lead the project and have infinite wisdom on everything. So there's I call it, there's no pesky maintainer that would show you like how stupid you are. No, there's a number of nice people. Everybody has their own niche, and overall, it's a generally nice experience. And also tolerant code of conduct. Again, very easy to contribute. Don't worry about the formalities too much. Another good thing, no rigid roadmap. So the demo, as I said, it's being organically grown as features show up in OpenTelemetry, as people come up with ideas, as KubeCon events come closer. So it's very, very different aspects that define what is being done next. And you can also raise your voice on the SIG calls or on the Slack. Regarding the participation, Slack is really my preferred way because it keeps the record. The SIG calls are really for the well-established members, but you can participate if you like, if you are brave enough to enter the call. So it's very easy to submit small PRs if you're starting, and really don't worry about mistakes. This is really not a big deal. Now, my case of building a custom or integrating a custom backend, it's specifically with a tool called Instana. It's part of IBM today. And what I did is build the demo so that it reports to the Instana backend. Fortunately, Instana has native OTLP, OpenTelemetry support. So that was my initial assumption, like this is no work. So I just turn off the default open source backend, the Jaeger, Grafana, etc., and I reroute the requests. But there showed up more things that would be worth integrating. So it actually turned out to be quite a time-consuming project and quite interesting thing to work on. So other than switching the backend, there's something called Instana Agent, which basically replaces the OpenTelemetry collector, which has its own specifics. And another interesting thing was infrastructure monitoring. So we are talking about OpenTelemetry, observability, but when we are talking about traces and metrics, we need to collect the data somewhere. So usually we do that with dedicated collectors. If you have a backend, a vendor backend, you might leverage that as something that is readily available. So combining the vendor-specific monitoring collectors plus OpenTelemetry is, in my opinion, a nice use case. There's also another very interesting use case, the mixed traces. There are some vendors that have proprietary instrumentation, proprietary format, and it's quite a nice experience to try to combine OpenTelemetry with some vendor-specific instrumentation, namely in the whenever you're dealing with context propagation, because OpenTelemetry uses the W3C by default, whereas there are also other standards, and the interaction between those it might be a little challenging. So let me move on. So here's a simple diagram. So basically, what I did initially was scratch the OpenTelemetry collector that ships with the demo and the Grafana Prometheus Jaeger backends, replace it with my backend. Well, as simple as it seemed, it really turned out to be more complex. Here are some screenshots of the demo as visualized in my backend. Some traces. If you're interested, I can of course show it to you after the session. So my last slide here is, what other experience I did have. So I have to state that not everything was ideal. So I'm trying to be positive here, but it's not everything was working out of box. Not everything was ready. So particularly those things that you see on the screen. For example, and I think this is a common thing that you will hear more often on this conference, that OpenTelemetry, it's an evolving project. It's not something rigid. It's not fully mature in some ways. It's mature in certain ways, but it's not mature in other ways. So what I found particularly for those of you who are Elixir or Erlang coders, you probably know the Ecto library for interaction with SQL databases. I'm not a coder in Erlang or Elixir at all, but I had to plunge in. I had to basically deep dive to figure out what was wrong, because my backend, what it does, it combines entry and exit spans. So basically the input, the beginning of the service call and the counterpart, and combines them into a call. So basically fully qualified call rather than a simple trace. So what I was looking for to find the matching span, entry and exit span, and I didn't see it in this case. So what I actually found out that there was a missing attribute or missing attributes in the library. Speaking about semantic conventions, again, you will hear more about that today. So this is something that was not there, and it's not there yet. It's not there today. It seems like it's abandoned. So not a great experience with Ecto instrumentation. My personal contribution was doing the client span for the Rust part, for the Rust service, shipping service, which was missing there. So again, not a big Rust coder, but I took a dive and figured it out. There was one kind of a rabbit hole involved here because the Rust programmers are very productive, and so whenever they do something, they do it properly. So when I implemented the client instrumentation, it turned out that it was generating like floods, tons of traces, and it was not a really nice experience after some time. So there had to be some tweaks so that we reduce the amount of granularity. Okay, so this is my my contribution here. Docker Hub, images, so those are the like recent things that we came across. Probably I'll stop here. One last thing, if you really want to get your hands dirty with the demo, anytime you are stuck, anything doesn't work, always increase the memory limits, because this is the most common problem people face. It's just not solved. I don't know why. So my last slide, thank you very much. If you have any questions, go ahead.
Thank you very much for your presentation. We have a question on our Slido regarding your probably last sentence. What's the performance impact of the OTel?
Performance impact of the OpenTelemetry in general. Well, you know, I think there have been books written about that. So I think this is really a matter of how you control OpenTelemetry. So you can get tons of spans or tons of data if you allow your instrumentation to collect it, and if you allow to pass it on to the backend. Yeah. So the performance usually there are multiple stages of performance. You can get stuck at your application, so the instrumentation really collects that much data that it has a negative impact on the application itself. You can also saturate the backend when you send too much data to the backend, and the backend may not be dimensioned to handle that. So there are multiple fronts to tackle that. So of course, sampling and various sampling methods are being devised, available. Whatever sampling methods, statistical sampling, tail-based sampling, etc. So this is all the complexity that comes with OpenTelemetry, and you will actually find it in the project as a very well described topic, and also other vendors have their blogs, their comments on that. So this is a generic answer. So my answer would be like it really depends, and it's up to you. The application developer who instruments the application to take care of the performance. Be cautious. What's going on? Understand what's being done. What data is being propagated, and then handle it appropriately.